You guys are going to need your science journals for today. And we are going to, if you read this little highlighted line, distinguish the various methods of measuring astronomical distances and apply each in appropriate situations. We're going to today look at how we measure stuff up in space. So what I would like you to do in your science journal, brand new page, write this question down, leave a couple lines underneath so that you can come back and answer this later on. All right. What do we use to measure the distances in space? First thing that I need you guys to know, space is huge. Space is bigger than you can think. You might think that space is big, but it's bigger than that. If I can get one point across to you guys this entire year, is that space is huge. Even teaching it for a couple years, space just still boggles my mind how big it is and how spread out everything is. Later this year when we start talking about galaxies and how far away they are and the distances in between, space is big. I'm running out of words to describe how big space is. Even when you look up at the sky and stars seem to be right on top of each other, they're not. They are many millions, billions, and trillions of miles away. In fact, there's no star that is a million miles away from the next. They're all at least trillions of miles away. So yeah, it's just big. Space is big. The universe is even bigger than what we can see. Like, it takes light a certain amount of time to travel because light has a speed limit, which means that there's part of the universe that's actually too far away for light to have traveled to us yet. So as big as space is and the universe is, there's actually more to it that we can't even ever know about because light hasn't gotten to us yet. Astronomers use units and methods that we don't use on Earth. So if I'm going to measure the size of my hand, I'm not going to use miles. If I'm going to measure the distance from here to Miami, I'm not going to use centimeters. All right, you need to use appropriate units to measure different things. When you're up in space, things are so spread out and so big that we are going to use units that we don't use here on Earth. First one is a light year. Not buzz, but a light year is how far light travels in 1 year. It's not a time. It has the word year in it, but it is not a time. It's the distance that light will go in 1 year's time. From us to our closest star, which is Alpha Centauri, actually Proxima Centauri, it's a binary star system, so there's two. That's about 40 trillion kilometers. It's much easier to write 4 than 40 trillion with all those zeros. So if we used kilometers, we would be writing zeros all day long, and that's our closest star. So if we're talking about something that is, on the next galaxy over, that's a lot of zeros. Much easier to use light years. So a light year is a distance. It is not time. It tricks everybody into thinking that it's time because it has the word year in it, but it's not. It is how far a distance light goes in 1 year. 1 light year is roughly 10 trillion kilometers. That's a big distance. Light will travel about 10 trillion kilometers in 1 year. It says 9.5 trillion there. I usually round just because it's easier to say 10 than 9.5. You can also have a light second, a light minute, a light hour, a light day, a light week, a light month, a light decade. That's all how far light can go in that amount of time. Light years are probably the most common, unless you're talking about how far does it get, or how far away is the moon. It's like 1 light second. It'd be stupid to use light years to talk about going to the moon. So we're not always going to use light years. We can use other units of time. Light goes about 300,000 kilometers in 1 second. So if we want to talk about going to the moon, we're going to use a light second. It takes about 1 second for light to get to the moon. If we want to talk about how long light takes to go from the sun to Earth, that's roughly 8 light minutes. So it'll take 8 minutes for light to travel from the sun to get to Earth. If you want to talk about going to Mars, light traveling to Mars, it takes 10 to 12 minutes. So Mars is about 10 to 12 light minutes away, which means if we're talking to the little rovers on Mars using radio waves, which travel at the speed of light, it can take 12 minutes or so for our signal to get to Mars. Our closest star, just mentioned, is about 4 light years away. Closest galaxy is about 2.5 million light years away. So a parsec is another unit of measurement, which sounds like a time because it has SEC. It sounds like second, but it's not. It's a distance. And a parsec is something that you are only ever going to see in astronomy. It's something that astronomers use. And it has to do with parallax. And parallax is that thing where you hold your thumb up and cover somebody's head, and then you switch which eye you're looking at your thumb with. And your thumb will appear to move. And the reason is that you're looking at your thumb with a different eye. So you're looking at your thumb from a different angle, which is why your thumb appears to move. Well, we do the same thing with Earth, looking at stars. If we have the Earth on one side of its orbit, and then 6 months later it's on the other side of its orbit, it's going to be in a different place, just like looking at your thumb with a different eye. We can look at a star when Earth is here on one side of its orbit, and it will appear to be next to that star. 6 months later, that same star will appear to have moved because we're looking at it from a different angle. And we've calculated that if that star appears to move 1 arc second, then it's, by definition, 1 parsec away. Turns out that's about 3 light years. The closest star is 4 light years. So there's no stars that are 1 parsec away. But we've calculated it. So a parsec is about 3 light years. And if you're talking, thousands or millions of light years, it can be easier to use parsecs because the numbers are going to be smaller. Keep in mind, this is not a time, it's a distance.
Han Solo. I'm captain of the Millennium Falcon. Chewie here tells me you're looking for passage to the Alderaan system.
Yes, indeed. If it's a fast ship.
Fast ship? You've never heard of the Millennium Falcon?
Should I have?
It's the ship that made the Kessel run in less than 12 parsecs.
What did you say?
Keep in mind that it is used to measure big distances, like between stars, between galaxies. It's not used to measure how far away the moon is. It's equal to about 3.2 light years, and it's calculated by having one star move 1 arc second when Earth is on different sides of its orbit. It's not a time. But we can actually calculate how far away that star is located. So when we start talking about how do we know how far away things are, well, we can actually use trigonometry. If we can measure this as 1 single arc minute, maybe it's a different number. We know how big this side of the triangle is. If we know how big this angle is, which we can calculate just by looking at it, well, then we're going to be able to use trigonometry to figure out that distance right there. And if we can figure out that, we can figure out how far away that star is. Up to about 300 light years away, we can calculate very accurately how far away stars are. That's how we know how far away Alpha Centauri is, about 4 light years, because it seems to move as we go around in our orbit. Once you get past about 300 light years, those stars are so far away that they don't really seem to move when Earth is going around in its orbit. They're just too far away. What I want you to do is draw this in your science journal. Draw this little diagram so that you have an idea of how parallax works in your science journal. The next unit is an AU. We learned about this first week of school when we were doing that math packet. An AU stands for astronomic unit, and it's the average distance between the sun and the Earth. When we are measuring things in our solar system, AUs is the way to go. If we want to know how far away a planet is, we're going to use AUs. If we want to know how far away Pluto is, we're going to use AUs. 1 AU is about 150 million kilometers. It's about 93 million miles. It's about 8 light minutes. It's just the average distance between Earth and the sun. And I say average because the Earth is not always the same distance away from the sun. The Earth travels in an ellipse, so sometimes it's closer, sometimes it's farther away, but the average is 1 AU. To get 1 light year in AUs, you would need 66,000 of them. So 66,000 AUs equals 1 light year. When you're talking about distant stars, using AUs is not going to be, the closest star is like 250,000 AUs away. It's easier to say 4 light years. I'd like you guys to draw this in your science journal. 1 AU equals how many kilometers, how many light minutes, how many miles. That way you have a visual representation of what an AU is. When you guys are looking at things in the solar system, you have planets. Earth is 1 AU away. You have Mercury at 0.4, Venus is 0.7, and then it gets kind of easy. Jupiter is at 5, Saturn is at 10, Uranus is at 20, Neptune is at 30. So 5, 10, 20, 30, kind of almost goes in order. Pluto averages about 39 to 40, but it can get as far away as 50, which means there are also times where Pluto is inside of the orbit of Neptune. You don't want to use light years because you're going to have a bunch of decimals. You don't want that. AUs is the most convenient and easy way to measure stuff in our solar system. Quick review: light years, unit of distance, not time. It's how far light goes in 1 year, roughly about 10 trillion kilometers. You can have light seconds, light minutes, light days, weeks, months. It's just how far light travels. 1 parsec is about 3.2 light years, and it's measured by using parallax, which is when stars seem to move when Earth is on different sides of its orbit. It's very good for big distances, like to the next galaxy or the next cluster of galaxies. And then you have AUs, which is what we use when we measure stuff within our solar system. When a light year or a parsec is going to be too big, we need a smaller unit, so we use AUs. The average distance between Earth and the Sun, about 93 million miles, about 150 million kilometers. Outside of our solar system, you're never going to use AUs. It's too small to use outside of our solar system. What I want you to do is go back and answer the question of the day in your science journal, and we are done.